in previous lessons we talked about solving trig equations like this, where we would go to solve this equation by saying I'd subtract 1 from both sides, getting 2 cosine x equals -1, divide by 2, giving you cosine x equals -1/2. We would then say, well, on what values on your unit circle does cosine equal -1/2? And we would say it's in quadrants 2 and 3. They happen to be at 120 degrees and 240 degrees, and those ended up being your answers. Well, what we're doing today is just a little extra step. The only difference between these two problems is what's inside this function, inside the trig function. In this one case it was x, in this case it's 3x. Well, guess what? We do nothing different. We still solve the same way to begin. Get the trig function by itself. So cosine of 3x equals -1/2. We still say, when does cosine equal -1/2? It's still 120 degrees and 240 degrees. The only difference is now, remember we said x equals those angles. Well, what's on the inside of the trig function? Because we really took the arc cosine function. So we'd say now 3x, because that's what's inside, equals 120 and 240. So then the only way to get x by itself would be to divide both of these numbers by 3. So my final answers here would be 40 degrees and 80 degrees. All you have to do is just one extra step, whatever's on the inside, to get that by itself. So here's a couple sample problems. Give them a try. See what you can get for your answers. Make sure you, again, get the final x by itself. Alright, this first guy here shouldn't have been too bad. You first had to isolate the trig function. Sine squared equals of 2x equals 3/4. Take the square root of both sides. So we get the square root of 3/4. That means I take the square root of top and bottom separately. The square root of 3 is just root 3. The square root of 4 is 2. So when does sine of an angle equal root 3/2? Well, there's 4 different angles because it's got to be positive or negative. So it's whatever 60 degrees is in all 4 quadrants. But that's what 2x equals. So to get what x equals, all I do is divide each of those numbers by 2 to get 30, 60, 120, and 150. Alright, for the second guy, I first have to get everything onto the left side of the equal sign because I have 2 different trig functions going on here. So I'm going to have sine of 1/2 x excuse me, equaling, or times cosine x, and then minus this cosine x over equals 0. Remember, I cannot combine these because they are not like terms. From there, I'm going to, if I can find it, factor out the common cosine. They each have a factor of cosine. Remember, this is like saying sine is like an x, cosine is like a y. So it would be like saying xy minus y equals 0. I could factor out this common factor of a y. So from there, now that I have 2 factors equaling a 0, that means I can set each one of them equal to 0. So I'm going to have sine of 1/2 x minus 1 equals 0, and cosine x equals 0 as well. You can get that dragged onto my screen here. From there, all I have to do is solve each one of them individually. So when does cosine equal 0? Well, that happens just when x equals 90 degrees or 270 degrees. Remember, cosine is the x value on your unit circle. So that should happen when you're at the top and bottom of the unit circle. And it's only x because, well, it was just cosine of x. To solve this guy, I would first bring the 1 over. So sine of 1/2 x equals 1. I would then say, when does sine equal 1? Well, that happens at 90 degrees and 90 degrees only. So 1/2 x, because that's the inside, equals 90. But I don't want 1/2 x, I want a full x. So I'm just going to multiply both sides by 2 to get rid of that and get x equals 180 degrees. So that means that my final answer are these 3 values, 90, 180, and 270 degrees.